last video ended on an abrupt note just because the video cut out and I didn't want to restart it. So in this video, we're just going to pick up where we left off. You'll remember last time we were working on Module 3 and we had just converted some numbers from decimals like 2.26 million to 226,000 written out. You know, it had the zeros in there. And it was turned into an integer. Okay, but so now we're on to this section, which is on just the right where we left off, which is adding new columns to lists. So let's just jump into it. Now let's add some new columns to a table. Now that we've already learned how to modify list elements, we'll need to add entirely new elements to each row list, which corresponds to cells in a new column. In order to do this, we will have to use the list method append, which adds new elements to a list. First, let's take a look at an example. So you can see here they originally had this list emoji that only has these 4 elements in it. And so they print it out and then they append winking to it and then they print it and now it has 5 elements in it. They've added winking, a whole new element to the list. The append method adds its argument to the list as a new element at the very end. New columns can be added by calling the append method in a loop. Let's give it a try on our table. We'll figure out the usage percentages of every emoji in the emoji mill column. Okay, so then they just show the table again. So you can see here the first thing we're supposed to do is add the next 3 elements to the list of emoji names using the append method. So here we have grinning, beaming, raffle, tears of joy, and winking. So if we go here, we have grinning, beaming, raffle, tears of joy, winking, and the next one will be happy. So we'll do emoji dot append quotes happy. Okay, and then it wants us to do the next one, which is heart eyes. And the next one is kissing. Okay, so if we run that, it says I completed it because when the video cut out, I had already done it. But that's what it looks like. You can see we've added the next 3 to the list. We hit next. Okay, so now create a new column in the table in order to show emoji usage totals across all 3 platforms. Then sort the table by this column in descending order and print the first 5 elements. The output is already described below. Analyze the statistics on emoji use based on the resulting new number. Okay, so the first thing it says is create a new column in the table in order to show emoji usage totals across all 3 platforms. Okay, so we basically need to have a total column, which is, you know, so you're going to have grinning, 2.26, 1.02, and then 87.3, and they want comma, and then a total. So how we're going to do that is loop through let's see. So we'll have for I in range 0 to the length of, what's it, data. So it's going to iterate through the loop, and I've made it the accessor version so we can change things in here. We're going to, for this first, it's going to first grab this one, or if we do, to get that list, what we need to do is data at I, and now we'll have that list, right? Okay, so data at I, we're now accessing this, and we want to append a new number to it, right? So we're going to append, and what are we appending? We're appending the sum of these 3 numbers, right? So it's going to be data at I at the, this is the 0th index, this is the 1 index, okay, plus data of I. Remember, all data of I is doing is grabbing this specific one, and then once the loop goes back around, it'll grab this whole one. And so that second indexer is going to grab 2.26, and then the next one's going to add 1.2 and 87.3. So you can see if I put 2 here plus data at I 3. Okay, so it's going to append the sum, and I'll put extra parentheses around it just to prove a point I don't think they're actually needed. What it's going to do is going to add all 3 of those columns together into a total and append it to that data spot. Okay, and so then it should go through and print that total. We also need to sort it, so let's do the sort afterward. Data.sort, and if you remember, let's see if it's in. We need to do a key equals lambda row colon, and then what are we sorting by? The last element in the list, which is 0, 1, 2, 3, 4, right? So it's going to be row equal row 4, okay? And then does it want descending order? Yes, so we do reverse equals true. Okay, so let's see if we did that correctly. We'll hit play. It looks like it's descending, and those look like totals to me. We'll see if that's actually right. Correct. All right, next. Normalization. The results have not improved very much. Recycle is apparently still in the top 5, but in the data we've been presented with, the scales of values for different platforms are incomparable. There are considerably more posts with emojis on Twitter than there are on the other 2 platforms. For this reason, it would be wrong to simply sum the post quantities. Let's pretend that we're comparing which creature is stronger, a human, a pigeon, or an ant. A human weighing 176 pounds can lift an 88-pound bag of potatoes. A pigeon weighing 8.46 ounces can fly with a letter weighing 2.82 ounces, and an ant weighing 0.00007 ounces can carry a leaf weighing up to 0.00352 ounces. It's not easy to compare them when you look at it that way. However, it's much easier to look at it this way. A human can carry half their weight, a pigeon can carry a third of their weight, and an ant can carry over 50 times its own weight. We have just applied normalization, meaning we divided the weight of each object being carried by the corresponding scale. We will have to do the same for our data. Here we are going to estimate the scale using the average value of the column. Let us calculate a new value with which to analyze emoji popularity. A scale is assessed as an average value for every column. Each value in the column is normalized or divided by this scale. Normalized values are then added together. Let's refer to this sum, the usage index. Let's refer to this sum, the usage index, okay? They give you the table. Calculate the mean values for all 3 platforms and then save them in the variables Emoji Express mean, Instagram mean, and Twitter mean. Print these values, see code, okay? So they already do the table for us, and then we need to get the mean for them. And so to get the mean, we need to get the sum right and then divide by the total. So we can do sum for emoji, or I guess they do it this way. They do the column first, emoji express sum equals the, well, let's initially set it equal to 0, and we'll do the same thing for Instagram. This was in a previous lesson. We did getting the mean, right? This was in the when we learned about length and stuff like that for lists. So Twitter sum equals 0. Okay, so then we need to loop through for, and since we're just going to store it in a variable, we don't need to change it in the list. We don't need to append anything. So we'll just do for element. We'll do for list in, and you can't use list because it's a keyword. So yeah, we'll just do for element in data. We will add to the emoji express sum. Emoji express sum plus equals, and emoji express is this first column. Well, so 0 and then 1. So it's actually the second column, but it's index 1 plus equals data, or I guess element And then we want, so element again is going to be this whole thing. And what we want is the 0 first index of that, which is 2.26. It's going to append that. And then for the Instagram sum, we're going to plus equals element at 0, 1, 2. So it's the second 2 index. And then for Twitter sum, we plus equal element at 3. Okay, so it's going to first get this element, and then it's going to add 2.26 to emoji express sum, add 1.02 to the Instagram sum, and 87.3 to the Twitter sum. And then it's going to go, in the next round of the loop, it's going to come down to beaming and add 19.1 to the emoji express sum, add 1.69 to the Instagram sum, and add 150 to the Twitter sum. Okay, so now we have a sum of all the elements. And now we want to get the mean for them and store them in new variables. So emoji express mean is going to be equal to emoji express sum divided by the length of data. Okay, so Instagram mean is going to be equal to Instagram sum divided by length of data, and the Twitter mean is going to be equal to the Twitter sum divided by the length of data. Okay, and then it should automatically format it for us. Let's see what that looks like. Okay, let's check it. Correct. Next. Okay, so we did this calculate the mean. So now we're on this calculate the usage index for every emoji, then add the resulting column consisting of these indices to the table. Okay, so we got the mean, and now it wants us to the usage index. Let's look at how they define that again. This is going to be similar to the for loop we had earlier, but it's going to add instead this usage index for every emoji. So we do for we're going to change the stuff in the list. So we need to use the index operator with the range in range from 0 to the length of data. We are going to append on data at I. Let's see, the usage index for every emoji. I'm still confused what that actually is. Let's refer to this sum. Oh, I think it's saying let's refer to this sum as the usage index. Okay, so it wants us to do this calculation for it. So we already got the average value for the columns. And so now we need to divide each one by the scale. Okay, so we're appending the emoji express value divided by the mean as another column in the table, I think is what they're trying to say. So it's worded weirdly, um, but but so for example, the emoji express normalized for this row is going to be equal to the data at I at the emoji express index, which is, so what's doing is emoji, this is what we did in like the first part of this video, is we are running through the data, we're grabbing this first row, okay, and we need the emoji express index at this row, which is this 2.26, which is index 1. So this is normalized data at 1. So this is what the value is before it's normalized, and they say the way you normalize it is you divide by the mean. So if we then divide this number by emoji express mean, that will get us the normalized emoji express value, and then they want us to append that as a column, right? So we append emoji express normalized. Okay, and they want us to do that for all 3 websites, so we can copy and paste this. Okay, and instead of emoji express this time, we're going to do Instagram, which is data I at 2, divide by the Instagram mean, and append that to the table. Okay, and then the last one is Twitter, right? So we'll do, and this time Twitter is the 3rd index in the table, and we're dividing by the Twitter mean, and we're appending Twitter normalized to the table. Okay, so if we run that, let's see what we get. Okay, let's see if that's right. We calculated the values of the variables correctly, but our output is incorrect. So what's interesting is they only are printing 1 usage index, but we have 3 different platforms. So I'm trying to figure out what. Oh, I see. So once we normalize the value, where they're going to add all the normalizations together, okay? And I guess it only wants us to append that result. Okay, so instead of appending all 3 of these, they just want us to add them together and then append that summed value. Okay, so we can do sum normalized is going to be equal to emoji express normalized plus Instagram normalized plus Twitter normalized. Okay, and so now we don't need to append these other ones because we're just going to append the sum. Okay, we'll kind of group the normalizations together and then the sum stuff together. So let's see. Okay, so then we get the sum normalized is this, and then we're going to append sum normalized. Might have a typo here. There's so many different variables I'm working with, but let's see. Okay, let's check that. Correct. Okay, cool. So as you can see, Tears of Joy is a big winner on all platforms combined. And Heart is really big as well. And let's see what happened to recycle. It should go down, right? Because, yeah, 1.96. Let's see what the third part is. As a final step to get the answer, we're going to need to sort the table by the added column and only print the first 5 elements. We've added the code to output the first 5 elements for the 3 source columns. The output should look like this. Okay. So let's see what they're already printing, and we'll fix it. Okay, so they have emoji name, they have emoji express mill, they have the line, emoji name Instagram mill, the line, emoji name Twitter mill, then the line, emoji name usage index. So the thing they're missing on the usage index is it's not sorted, right? And there's not 5 of them, so that's what we need to fix. Okay, so we need to data.sort from the 4th row because that's the usage index, descending, so reverse equals true, and then for row in data up to 5 because they only want the first 5 rows. Okay, so let's see if that fixes that. Yep, tears of joy and heart, just like we were saying before. And heart eyes is big, and kissing is good, and happy. Okay, so let's check that. Correct. Conclusion. We finished module 3, it looks like. The most popular emojis are the ones linked to positive emotions, happiness, and love. The ranking order of emojis may be different on various platforms, but the most popular emojis are the same across the board. Individual websites have their own idiosyncrasies that generate outliers, as in the case of the recycle emoji on Twitter. Artifacts can be avoided by collecting values from all platforms and then normalizing them. What's next? Our first investigation was so successful that you could even show it to an industry professional with confidence. You've managed the necessary stats to prove our hypothesis. You have also learned how to convert lists into tables and sort values, as well as identify the anomalous values. So can't you just use any ordinary program from any old Office software suite that works with tables and forget about Python entirely? Technically speaking, yes, but knowing a programming language is crucially important. It allows you to create specialized tables as well as write your very own functions. Functions that have never been written before. Functions that are able to make critical decisions in response to the sheer magnitude of values. In the next chapter, we will learn how to set conditions for any program and make our very own program with enough program functions. So onwards and upwards we go. You're finally about to do some real deal programming. Cool. And with that, that'll be the end of this video. Thank you guys so much.